Assalamu alaikum wa rahmatullah. Today we will start with Chapter 16, Polynomials, Part 4. Our objectives are: recognize the meaning of monomial, similar monomials in one variable. Recognize a polynomial in one variable. Reduce and arrange in order the terms of a polynomial. Determine the degree of a polynomial. Add, subtract, and multiply polynomials in one variable. We need the following materials: textbook, draft papers, pen, and calculator. Definition. We call monomial in X the expression a x exponent n. A is a real number called the coefficient. X is called the variable. N is a natural number and is called the degree of the monomial. Example 1. Minus 3t squared is a monomial in t since it is of the form ax exponent n. Minus 3 is the coefficient. T is the variable. Its degree is 2, which is a natural number. Example 2. 2 radical 5x exponent 4 is a monomial in X since it is of the form ax exponent n. 2 radical 5 is the coefficient. X is the variable. Its degree is 4. Important remarks. A non-zero constant number is a monomial of degree 0. Example, minus 3, 2 over 5, 2 radical 6 are monomials of degree 0. 0 is by convention a monomial with undetermined variable and degree. Example 4. 4 over x, where x different from 0 since x in the denominator, is not a monomial since 4 over x equal 4x exponent minus 1, because the rule a over b equal to a times b exponent minus 1, and the exponent minus 1 is not a natural number, so it is not a monomial. Example 4. Minus 2 radical x, where x is a positive number, is not a monomial since it cannot be written in the form of ax exponent n, where n is a natural number. Application. Complete the following table. Please pause the video and try to solve it. Solution. Minus 9 over 2a exponent 5, where a different from 0 because a in the denominator, is not a monomial, since we have the variable in the denominator, and we know that the monomial is a number, a variable, or a product of number and variable. Radical 5x cubed is a monomial, since it is of the form ax exponent n. The coefficient, radical 5, the variable x, and the degree is 3. Minus 7 is a monomial, since it is a number. The coefficient, minus 7, the variable, undetermined, and the degree is 0. Minus 2 radical y, where y is a positive number, is not a monomial since it is not of the form ax exponent n. Similar or like monomials. Monomials in the same variable are called similar or like monomials if they have the same degree. Examples: minus 2x squared and radical 5x squared are similar monomials since they have the same variable x and the same degree 2. 5 over 4y cubed and 3 over 7x cubed are not similar monomials since they have different variables x and y. Radical 3x exponent 5 and radical 2x exponent 2 are not similar monomials since they have different degree. Here we have 5 and here we have the degree is 2. Definition. A polynomial is the one monomial or the sum of unlike monomials. Each monomial is called a term of the polynomial. A polynomial in X is denoted by P in X, Q in X, A in X, etc. Important remarks. A polynomial of two terms is a binomial. Example, A in X equal x cubed minus x squared is a binomial in X since it has two terms, x cubed and x squared. A polynomial of three terms is a trinomial. Example, B in X equal 5x exponent 5 minus 3x squared plus 7 is a trinomial in X since it has three terms. Example 1. P in X equal minus 5x cubed plus 2x squared minus 3 is a polynomial in X, which means X is a variable. The monomials minus 5x cubed, 2x squared, and minus 3 are the terms of P in X. Example 2. Q in T equal 3t exponent 5 minus radical 5 is a polynomial in T, which means T is a variable. 3t exponent 5 and minus radical 5 are the terms of Q in T. Example 3. A in Y equal 6y cubed minus 5 over y plus 3 is not a polynomial since The term minus 5 over y is not a monomial because the variable in the denominator, and we know that the polynomial is a sum of unlike monomials, and here we have 5 over y is not a monomial, so a in y is not a polynomial. Ordered polynomials. The polynomial is said to be ordered if its terms are written in ascending or descending order of their degrees. Remarks: a polynomial is said to be reduced if it contains no similar terms. That is, to reduce a polynomial is to perform the sum or the difference of its like terms. Also, to reduce a polynomial, you may order its terms in descending order of their degrees. Example: p in x equals 6x cubed minus 5x exponent 4 minus 1 plus 3x can be written as minus 5x exponent 4 plus 6x cubed plus 3x minus 1. Pay attention. We arrange it from the greatest degree to the smallest degree. The degrees are 4, 3, 1, and 0. So we arrange from the greatest to the smallest. It is ordered in descending order. Or we can write minus 1 plus 3x plus 6x cubed minus 5x exponent 4. Pay attention here. We arrange from the smallest degree to the greatest degree. The degrees are 0, 1, 3, and 4. So it is ordered in ascending order. Example 2. To reduce the polynomial r in x, we order r in x in descending order. So we arrange from the greatest degree to the smallest degree, and we put the like monomials beside each other. We reduce them to x cubed plus 5x cubed, we get 7x cubed, minus 3x squared plus 6x squared, we get 3x squared, plus 1x plus 4x, we get plus 5x, minus 1 minus 5, we get minus 6. And then it is in reduced form since it contains no similar terms. Application. Consider the following polynomial p in x. Reduce and order p in x in ascending order, then in descending order. Please pause the video and try to solve it. Solution. We need to put it in ascending order, so we start with plus 1. Since the degree of the number is 0, we arrange from the smallest degree to the greatest degree. So we start with plus 1 because the degree of the number is 0. And then we reduce plus x over 3 with minus 2 over 3x to get minus 1 over 3x. Here the degree is 1. We put plus 3x squared since we haven't a monomial similar to it. Finally, we reduce x cubed with minus 2x cubed with minus 5 over 2x cubed to get minus 7 over 2x cubed in ascending order because from the smallest degree to the greatest degree. Now we need to put it in descending order, so we arrange from the greatest degree to the smallest degree. Degree of a polynomial. The degree of a polynomial is the greatest degree of its non-similar monomial terms. The notation deg will be used to mean degree. Pay attention. The degree of a polynomial is specified after reducing it. Example 1. p in x equal minus 1 over 5x cubed plus 4x squared minus 1 is a reduced polynomial since it has no similar terms. So the degree of p in x is 3 because the degree of a polynomial in one variable is the greatest exponent of this variable of the reduced polynomial. Example 2. b in x is an unreduced polynomial. To find the degree of b in x, we must reduce and order the terms. It is unreduced because it has like monomial, so we must reduce them. 2x exponent 5 with minus 2x exponent 5, 0. We eliminate them since they are opposite. And then we reduce plus 5x squared with plus x squared to get 6x squared. We put minus 3x because we haven't a monomial similar to it. And then we put plus 3 and we arrange it in descending order because we put from the greatest degree to the smallest degree. The degree of b in x is 2 because the degree of a polynomial in one variable is the greatest exponent of this variable. Example 3. g in t equal minus 4a exponent 3 t exponent 5. A is a non-zero real number. Pay attention here. Since it is g in t, so the variable is t and the coefficient is minus 4a exponent 3. So the degree is 5 since it is the exponent of the variable. Example 4. k in y equal minus 2y exponent 5 into 7y. We multiply minus 2 by 7 and y exponent 5 by y to get minus 14y exponent 6. The degree here is 6 since it is the exponent of the variable. Application. Find the degree of the following polynomials. Please pause the video and try to solve it. Solution. Part 1. To find the degree of this polynomial, we must reduce the like monomials first to get t minus 2, and then the degree is 1 since it is the greatest degree. Part 2. We multiply the coefficients and then we multiply the variables to get minus 3x exponent 6. The degree is 6, which is the exponent of the variable. Sum and difference of polynomials. The sum or difference of two polynomials in the same variable is a polynomial whose degree is less than or equal to the greater degree of the two polynomials. Example. Consider the following polynomials: a in x, b in x, and c in x. Find the degree of a in x plus b in x and a in x minus c in x. a in x plus b in x equal 3x exponent 4 minus x squared plus 2x, which is the polynomial a in x, plus 2x squared minus 5x plus 1, which is the polynomial b in x. Here we can remove the parentheses directly without changing any sign since we have plus. And then, after we remove the parentheses, we reduce like monomials to get 3x exponent 4 plus x squared minus 3x plus 1. Degree of a in x plus b in x equal 4, which is the greatest degree. Notice that a in x plus b in x is a polynomial and degree of a in x plus b in x equal to degree of a in x. a in x minus c in x equal 3x exponent 4 minus x squared plus 2x, which is the polynomial a in x, minus 3x exponent 4 plus 5x squared minus 6, which is the polynomial c in x. Here we put the parentheses since we have minus before it. And then when we want to remove the parentheses, we must change all the signs inside this parenthesis because we have minus. After we remove and then we reduce like monomials to get minus 6x exponent 2 plus 2x plus 6. The degree of a in x minus c in x equal 2. Notice that a in x minus c in x is a polynomial and degree of a in x minus c in x less than degree of a in x. Product of polynomials. The product of two polynomials in the same variable is a polynomial whose degree is equal to the sum of the degrees of the two polynomials. Example, consider the following polynomials: a in x equal 3x exponent 4 minus x squared plus 2x, and b in x equal to x squared minus 5x plus 1. Find the degree of a in x times b in x. Degree of a in x equal 4, because it is the greatest degree between the terms of the polynomial a in x. And degree of b in x equal 2, since it is the greatest degree between the terms of the polynomial b in x. So, degree of a in x times b in x equal degree of a in x plus degree of b in x, which is equal to 4 plus 2 equals 6. Notice that a in x times b in x equal 3x exponent 4 minus x squared plus 2x between parentheses times 2x squared minus 5x plus 1 also between parentheses. To multiply these two parentheses, we must multiply each term of the first parenthesis by all the terms of the second parenthesis. And then we reduce like monomial to get 6x exponent 6 minus 15x exponent 5 plus x exponent 4 plus 9x cubed minus 11x squared plus 2x. The degree here is 6. a in x times b in x is a polynomial since it is the sum of unlike monomials. Application. Consider the following polynomials: p in x and q in x. Part 1. Calculate the sum and the difference of the two polynomials. Part 2. Specify the degree of p in x times q in x, then calculate p in x times q in x. Please pause the video and try to solve it. Solution. Part 1. 3x squared minus 3x minus 4 between parentheses, which is the polynomial p in x, plus 3x squared minus 2x plus 1, which is the polynomial q in x. First, we remove the parentheses without changing any sign since we have plus. And then we reduce the like monomial to get 6x squared minus 5x minus 3. p in x minus q in x equal 3x squared minus 3x minus 4 between parentheses minus 3x squared minus 2x plus 1 between parentheses also. Then we remove the parentheses by multiplying all the terms of the second parenthesis by minus and we reduce the like monomials to get minus x minus 5. Part 2, degree of p in x times q in x equal degree of p in x plus degree of q in x. Degree of p in x is 2 and degree of q in x is also 2. We add them to get 4. P in x times q in x equal 3x squared minus 3x minus 4 between parentheses times 3x squared minus 2x plus 1 between parentheses. Then we multiply each term of the first parenthesis by all the terms of the second parenthesis, and we reduce the like monomials to get 9x exponent 4 minus 15x cubed minus 3x squared plus 5x minus 4. This is your homework, and this is the summary of our lesson. Thank you for watching. Wassalamu alaikum wa rahmatullahi wa barakatuh.